Okay, during monostable multivibrator circuit, it has a stable state and quasi-stable state. This has a trigger input to one transistor, so one transistor changes its state automatically while the other one needs a trigger input to change its state. As this multivibrator produces a single output for each trigger pulse, this is known as one-shot multivibrator. This multivibrator cannot stay in quasi-stable state for a longer period while it stays in stable state until the trigger pulse is received. So that means one stable, one is unstable. So that stable state, when you trigger it once, that stable change to unstable state. So how they construct that monostable multivibrator? Two transistor Q1 and Q2 are connected in feedback to one another. The collector of transistor Q1 is connected to the base of transistor Q2 through the capacitor C1. The base Q1 is connected to the collector of Q2 through the resistor R2. That's the difference from the previous multivibrator. And capacitor C, another DC supply voltage VPP, is given to the base of transistor Q1 through the resistor RC. The trigger pulse is given to the base of Q1 through the capacitor C2 to change its states. RL1 and RL2 are the load resistor of Q1 and Q2. One of the transistor, when gets into stable state, an external trigger pulse is given to change its state. After change its state, the transistor remains in this quasi-stable state for a specific time period, which is determined by the value of RC time constants and get back to the previous stable status. So it looks like this one, monostable type. It is one triggering to the base of Q1 or transistor 1. The other Q2 is as the same with a stable from this C1. They get it. So if, let's say example, quasi-stable or stable state from this Q1, after trigger 8, this Q1 becomes unstable. So let's see how they operate. Firstly, when the circuit is switched on, transistor Q1 will be in off state and Q2 will be in on state. This is a stable state. As Q1 is off, the collector voltage will be VCC at point A, and hence C1 gets charged. A positive trigger pulse applied at the base of transistor Q1 turns the transistor on. This decreases the collector voltage, which turns off the transistor Q2. The capacitor C1 starts discharging at this point of time. As the positive voltage from the collector of transistor Q2 gets applied to the transistor Q1, it remains in on state. This is a quasi-stable state. The transistor Q2 remains in off state until the capacitor C1 discharges completely. After this transistor Q2 turn on with the voltage applied through the capacitor discharge, this turn on the transistor Q1, which is the previous stable state. So this is the principal operation of for monostable circuits. So the output wave before triggering, let's like this one, Q1 off, Q2 on. After triggering Q1 on, Q2 off, it's unstable output. We can get the out waveform as a collector of Q1 and Q2 along the trigger input given as the base of Q1 are shown in the feature. So this is the output wave signal. So the width of this output pulse depend upon the RC time constant, hence it depends on the value of R1 C1. The duration of the pulse is given by period becomes 0.69 R1 of C1. So the trigger input given will be of very short duration just to initiate the action. This triggers the circuit to change its state from the stable state to quasi-stable or semi-stable state, in which the circuit remains for short duration. This will be one output pulse for one trigger pulse. Advantage for monostable, one trigger pulse is enough. Circuit design is simple, also inexpensive. The disadvantage or the major drawback of the monostable array is that the time between the application trigger pulse rate has to be greater than the RC time constant of the circuit. So at what time you are trigger that circuit? That is a drawback of monostable type. Where they apply monostable multivariators. So the monostable multivariators are used in applications such as television circuit and control system circuits. Let's see, the third type of multivibrator is bistable multivibrator. A bistable multivibrator has both the two states stable. It requires two trigger pulses to be applied to change the status until the trigger input is given. This multivibrator cannot change its state. It's also known as flip-flop multivibrator. That is the second name of bistable multivibrator. As trigger pulse sets or resets the output, and as some data, that means either high or low, is stored until it is distributed, this multivibrator can be called as flip-flop. Two similar transistors Q1 and Q2 with load resistor RL1 and RLs are connected in feedback to one another. The base resistor R3 and R4 are joined to common source of negative VPP. The feedback resistor R1 and R2 are shunted by capacitor C1 and C2 known as commutating capacitors. The transistor Q1 is given a trigger input as the base through the capacitor 3, and the transistor Q2 is given a trigger input at its base through the capacitor C4. The capacitor C1 and C2 are also known as speed up capacitors as they reduce transition time, which means the time taken from transfer of conduction from one transistor to the another transistor, thus capacitors. So it looks bistable multivibrators. C1 with R1 in parallel, that is what you said for speed up capacitor purpose, thus capacitor 1, capacitor 2. So that from this collector to the base of Q1, from this collector to the base of Q2. So both of them are in the output we can get by triggering. If you need high, trigger 1. If you need low, trigger 2. That becomes stable. Both sides are stable output. So when the circuit is switched on, due to some circuits imbalances as unstable, one of the transistors say Q1 gets switched on, while the transistor Q2 gets switched off. This is stable state of the bistable. By applying a negative trigger as the base of transistor Q1 or by applying positive trigger pulse as the base of transistor Q2, this stable state is unaltered. So that's principal operation. When you applied that positive or negative trigger, that becomes changed the state of the signal in the output. So to understand this, by considering a negative pulse as the base of transistor Q1, as a result, the collector voltage increase, which forward biases the transistor Q2. The collector current of Q2 as applied as the base of Q1 reverse biases Q1, and this cumulative action makes the transistor Q1 off and transistor Q2 on. This is another stable state of multivibrator Now, if the stable state has to be changed again, then either a negative trigger pulse at transistor Q2 or a positive trigger pulse at transistor Q2 is applied. So, after triggering, it's changed. Look it. It's one of them high, low. So after again trigger, low, high. So the output of your corrector of Q1 long with the trigger inputs given at the base of Q1 and Q2. These wave shapes. After triggering, we can get high or low. If you not trigger it, that becomes stable output. It may be low or it may be high is a stable state. So the advantage, what are the advantage of bistable? Stores the previous output unless disturbed. That is flip-flop circuit. Circuit design also is simple. What are the drawback of this bistable? Two kind of trigger bursts are required. A bit costlier than the other multivibrators. So where they apply bistable multivibrator are used in applications such as pulse generation, digital operation like counting and storing of binary informations. So these are about multivibrators. If you have any question or suggestion, please put on the comment box. Thank you.